area in the first quadrant, right? Y equals 2x. I'm just drawing this so we get some idea what's going on here. And this is 0 at 0, and it's going to look a little like a parabola. You could figure that out by plugging it into the calculator. So, you know why it says what? Oh, the first. Why did it say the first quadrant? Well, anyway, it looks like both of them pass through 0, 0, and it looks like they'll pass through some other point. So how do we find that? Well, we can look for the x, where they pass through each other by setting 2x equal to x squared of 3x squared plus 1. Well, that's going to be, let's see, 0 equals, doesn't matter, 2x minus x squared, 3x squared plus 1, which would be x times 2 minus square root of 3x squared plus 1. Well, that's the 0, right? X equals 0. So let's see what that equals. If that's equal to 0, 2 minus square root of 3 plus 1 equals 0. 2 equals the square root of 3x squared plus 1. 4 plus 3x squared plus 1 equals 3x squared, or x plus or minus 1. Well, I'm not even sure if the minus 1 is real. Probably it is. Maybe it goes like that, but we don't care because it's the first quadrant. So we have x1, y2, right? 1, 2, times 1. Okay, so what we want is to integrate from here to here, from 0 to 1, the difference between these two. So the upper one happens to be 2x.
The 0 to 1 is given, right? That's what they tell you. Or did you just figure that out?
I had to figure that out. They said find the area in the first quadrant between, between these two. All right. So again, this point is easy to figure out. Let me write this down. Y equals 2x. Y equals x squared 3 squared plus 1. 0 is easy to see. But I have to go through this process here, equating these two, and to see where the other x is, where they meet. So it's going to be the upper one minus x squared 3 squared plus 1 dx. So that's just like the setup. So now you have to integrating this is easy, unless you have the boards in the wrong place. Let's see here. So, we can break this up. This is 0 to 1, 2x minus 0 to 1, x squared, 3x squared plus 1. And this looks like I'm going to say this looks like substitution, but let's try u equals 3x squared plus 1. So du equals 6x dx. Well, we can make this look like that. 6x dx, and then 1/6 square root of 2x squared plus 1. Right? So this becomes, I'm not going to change these. I could, but it becomes 1/6 square root of u du. And outside constant. So this x to the 1/2, u to the 1/2. So it's going to be 1/6 the integral u to the 3/2 over 3/2. And that's going to be 1/6. Okay, u is 3x squared plus 1 for 3/2 over 3/2, which is 2/3, 0 to 1. And this looks like 1/9. 1/9. 3x squared plus 1, 3/2. Okay, so that's 1/9. Let's plug in 3 plus 4 to the 3/2, so that's 8. Minus, so that becomes 1. So that's 7/9. But that was just this part of it, right? We're subtracting 7/9. This becomes, this is the easy part. This is x squared from 0 to 1. So it's 1 minus 0, so it's 1 minus 7/9, 2/9. So we should be suspicious that I've made a stupid error somewhere, and let's just plug it in and see. In other words, it's much easier to check this way than it is to go through all this in great detail and hope we can find any problem. Square root of 3. Look right? Yeah, it does. And so find integral from 0 to 1, and it tells me it's 0.222222, which is just what I'd expect.
So it's 7 over 9?
It's 2 over 9.
Okay.
It's 1 minus 7 over 9.
Okay.
This integral here, this part, 7 over 9, and this is 1. Catch up here. Other questions? Now that's interesting. These are both TI-84 pluses, but they work differently.
Is one older?
Probably. one of them, when you tell it, you know, x squared, it goes, it's like this. The other one, puts something up over here, and you have to move over. Like, I could say plus here, but on this one, if I say plus, the plus goes there. So you have to kind of move over to get plus there.
I think the newer one's like that. You have to move over for the plus.
Yeah, it's sort of an improvement in visually, however, makes it easier to make a mistake. Entering stuff.
Did you charge those?
You do one
Sure. This is office hours. I'm here for you. For you and my Milky Way.
So much homework to do. Yeah, do you only have so I'm going to sign up for this SAT boot camp thing? Can't decide whether I'm to or not.
After doing an SAT,
Yeah, but it ends in the summer. Summer is boot camp. They have a boot camp class.
is that only
Yeah. No, man, I don't know if I want to do that.
Eric, put something on the board? Or?
You want me to put it on the board?
I don't even know. It's
You want me to put it on the board?
Or tell me what you want to do.
Yeah.
I think the expectations are a little too high.
I just like.
But I might as well, I mean, I never know.
They know what
I'll always be wondering for the rest of my life. What?
Craig.
What?
Well, again,
Yeah, I think so.
It's in crosswalks, so I don't know.
I think I'm going to sign up for email. It's all free sales call. Yeah. And you have to get free textbooks and everything, every class.
Picture always
So my
helps.
friend from my other class.
So,
so
negative x squared, it's an upside down parabola starting up here at 5. And this is a negative slope, but it starts at 3. So we want to find, you know, what these points are, because we want to integrate from here to here. So we set them equal. And what do we get? We get x squared minus x minus 2
But
equals
you
0.
already submitted it, so we don't change
Yeah. So this is going to be
it. I think.
hopefully 2 and 1 minus 2 plus 1, which means this is at minus 2 and this is plus 1. So that pretty much sets it up for us.
Is it a negative one? And then plus 2.
Everything plus.
Yeah.
Yeah, but this is like an especially.
So you gotta watch out for this stupid minus 1 plus 2. So that means that the integral we want is from negative 1 to plus 2 of the upper one minus the lower one.
So you always do upper minus lower?
Well, if you know. If you don't,
Well, I guess I money back.
then you just go like that.
Okay.
No, I'm saying absolute value, or even better. If you know, see, if you got one that looked like this,
Right, because then if it's negative, it's just still the same.
right? Then you've got 3 points, right? And you need the absolute value between here and here, and the absolute value between here and here. But here, the worst is it could come out negative, and then I just change the sign. that.
Right, but how many does it?
So, okay.
She probably did the order of the.
So this is negative x squared plus x
Even though you're in the middle.
plus 2. And then this is negative x cubed over 3 plus x squared over 2 plus 2x from negative 1 to 2. So that's negative 8/3 plus 2 plus 4 minus, okay, that'll be 1/3
I don't know how they look like.
plus 1/2 minus 1. So it would
Okay,
be
fine, I'll forget it, but it's not my fault, it's,
minus plus. So negative 9/3
if the food's wrong.
6 plus
If
7
the order's wrong. You're not checking it.
minus 1/2. So this is minus 3 plus 7 minus 1/2. It's 4 minus 1/2, so 3.5 or 7.5. I'm better at calculus than fractions, but I can do fractions. Okay, again, I think,
Yeah, I just wanted to like,
it's worth checking. Yeah. Sure, why not? Minus x squared plus 5 minus x plus 3 minus 1 2. Then it's 4.5. So I did something wrong, probably something to do with the half. So that was 4 minuses. This was minus. So there's 4 minuses here, so that's 1/3. Plus 1.5 minus 2.
I should have. Yeah, kind of better.
Did I enter it wrong? X squared minus 5 minus x plus 3. Six, 7, oh, this is 8. I can't add. So it's 9/2. Yeah, I guess I'm better at fractions than straight adding numbers, integers. Oh. Now, Bruna, I just have to ask, you do know if it wasn't due today, right? Okay, all right. Because if you didn't know that, that means I'm a poor communicator. Can I erase this?
Yeah.